free fall. Then what is this?
Free fall.
I don't know. You don't know what you're doing. So how will you know what are you doing? So both of us don't know. Okay? So the problem, don't do that. Okay? This is free fall. Don't do when free fall comes, don't do this experiment. So just go there and start doing this. Then where is the table for this doctor? So you table for this. You're free fall. Which is free fall? I said, I don't know. Find out.
But I don't understand. How can he do this experiment?
Neither I understand.
When the procedure.
Neither I understand. Because they don't read anything. They just come and start doing whatever they want. Okay? Then this doctor, this table is different. I said, your table is not table different. Understood? So be careful. Don't do those things. You will lose, don't get marks. You'll waste time in the lab, 1 hour, 2 hours for nothing. Right? Okay. Now how to adjust the height? How to adjust the height? So you'll keep that. For example, let us say I want this small ruler.
So.
A small ruler. Now see, for example, okay, I want to make height. Let's say I want to make height how much? 60. Okay, let's say 60. I want to make height 60. Where is 60? 60 is here. Okay, 60 is here. Right? You're alone in the lab. You're alone in the lab, right? So you don't have partners. Yes? So you should know how to do it. So don't say, sir, alone I cannot do. You have to do. This 60. Okay, this is 60. It should be the 0 should be on the sensor, on the pad. Okay? 0 should be on the pad here. Here, 0. And in this case, 0 will be here. You see opposite. Don't make opposite things. Here, 0 should be near the length, near the fixed end of the string. But here, the 0 should be on the sensor pad. Okay? Remember, don't keep 0 up. You can't do that. 0 here. Okay? Now, how much you said?
60.
You said 60, right? Okay, 60 is here. Okay? So I have to move it down. So I'm alone. I'll do some adjustment. I'll just bring it down. I'll bring it here, okay? And see what happens. Now see here. I'll again check. Yeah, I came near 60, right? But see, it is above, right? It is above. So what you can do, you can just move this thing. You can move and bring to the height. Understood? So this adjustment you can always do. Bring this to the height. Keep here. On 60, 60, yeah. The bottom, okay? The bottom should be at 60. I brought it, right? So adjustment of 3 to 4 centimeters you can do by moving this up and down. So you don't have to mall that. Just bring it approximately close to that level. Then you can just rotate this, okay? And bring it to the bottom of the ball. The bottom of the ball should be at 60, not the middle, not the top. From the sensor. Okay, from sensor, the 0 should be on the sensor, and the bottom of the ball should be at the readings that you need. Understood? Okay. Next, this timer should be kept in. Okay, it should be kept in which one? Where is the? Okay, there should be pulse mode. Okay, sorry, time and 2 gates. This should be on time and they should be on 2 gates. Time and 2 gates. Okay. Use this red button to make it time and blue button to make it 2 gates. Okay. Okay. Now, once you put the ball here, okay. Now you toggle it. If I put it, you will get the reading. Okay. Now, where is this toggle switch? Okay. Now, see when you press this here, before pressing, please bring the star. Bring the star, okay? And just press it off, okay? You must get the time. I don't know, there's some problem, okay? Off. So you'll get the time, okay? You'll get the
Time.
Once you get the time,
Can you just explain again the 2 gates and
this
all that
is
stuff?
time
Yes.
and 2 gates. Time and
2 gates.
2 gates.
Okay.
Then you see there is light here. Okay? There is a light. You have to be careful. Okay, this light. Okay, before you start, keep the ball here. Keep the ball here. And what you do? Press the star. Okay, you'll get the time. You'll get the time.
And of course, gate number 1 is this one, and gate number 2 is this one.
Yeah. Okay.
Yeah.
Okay. Now second, it will be set. Okay, it will be set for you. We will not ask you to fix this. Okay. If you make mistake long time ago, it will be set. Everything will be set. Those things. Testing. Now, see now is this light blinking? See next trial. Okay. You see next trial again. Remove the star. Keep the ball. Bring the star. Drop it. Okay. Now see take the reading, but this light is blinking. Don't start the experiment until this light stops blinking. This light must stop blinking before you start the next trial. Okay, stop right.
Yep.
Put the ball, then bring the star, then exit. Okay, then again this light is blinking. Don't do anything. Let it stop blinking
Question: what does that mean?
because it is resetting. It is an electron circuit.
Okay.
It is some time. It slips. After reading, it slips. It becomes it goes to the saturation region. Advantage electrons. Okay? This setup goes to it goes saturation. It won't come active. So after some time, it becomes active. Okay. This is there is some computers slow, some computers are fast. Computer.
Yeah.
Your mobile is the same thing because the sleeping time. The sleeping time is more for them, so they don't get up quickly. New phones, high quality phones, fast. 200 kD, 300 kD, tuck, 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 you press it. 20 kD phone, this one, okay, put it here. Then press reset, drop it, then light should go. Hold the ball, okay? Don't keep it back. Let the light stop blinking. Okay, still?
Yeah,
Okay,
no.
now put the ball, then press the star. Then start, okay? That's it. Then only calculation. Okay. Let's go to this one. This is a pendulum, okay? Okay, this year you did together in the lab, okay? But in the exam it will be separate. You did this and this together. But in the exam it will be one experiment and one experiment. Okay? Now, this is very easy. Height should be, 0 should be here. 0 should be here. This is the 0 point. Understood? If I say 50, if I say 60, let us say I want to say what? How much? 60. So keep 0 here on the top and pull the center of the ball to 60. Pull the center ball to 60. Yeah, center. Center of the ball, not the bottom. Here, bottom, but here, center of the ball. Okay. Now light sensor is here. So light is coming from here to here. Yeah. So this one you must bring it to the center. This one must bring it to the center. Okay, there's check for everything. There is a check for everything. You will know you're doing right or wrong. How? In that setup. In the first one. Okay. In the density. How will you know you're right or wrong? If I give anything, I will not give one aluminium, one brass, one copper. I will not give. I'll give all the cylinders of aluminium, or I'll give all the cylinders made up of brass. Of one material, I give something made up of only one material. Okay. So when you calculate the density, it should be close to each other. For example, aluminium. What is the density? 2.7.
Okay.
So you must get 2.7, 2.8, 2.65. You can't get 2.7, 3.9, and 2.1. The moment you get 3 different densities, you're wrong. So immediately you will know that you're not making correct. So don't expect any marks. Understood? So because we will not know which reading is wrong. Maybe diameter wrong, maybe length wrong, maybe mass wrong. We can't make out. Understood now? So the moment we see 3 densities different, you will know what you're doing. Okay? In that experiment, acceleration. In that one, okay? Acceleration should come same because acceleration is g sin theta in kinematics. Once I put the stones, the angle is fixed. A is equal to g sin theta. So once I put the stones here, angle is fixed. Once angle is fixed, sin theta is fixed, A is fixed.
Do you have a protractor to see the angle, or
No.
is it kept?
The moment I put the mass there, 2 to mass, I don't change it. For beginning till the end, I keep the same stones, right?
Okay.
So the value of A should not be different. They should all come same. If they come different, 0.1, 0.15, 0.19, you're wrong. So that's the check. You have a check. The moment you do the experiment, you can check you're right or wrong.
Okay.
Yeah. This one, what is the value of G?
G is
9.8.
9.8.
So you can get 9.9, 9.75, 9.8, around that.
Okay.
Not one value 10, 1.8, 1.15. In physics you get 0.
Yeah.
In maths you get 100. What is the average?
I'm sorry?
In physics you get 0.
Okay.
In maths you get 100. What is your average? 50. But did you pass in maths?
No.
No, because you got 0 in physics. You failed. You can say average is 50, but you failed. So average is taken only for those values which are close to each other. Average is not taken for 0 and 100. Average is taken only for 95, 97, 98. The numbers are close, you can take the average. Don't say average of 0 and 100 and say I got 15 physics, 15 maths. No, you got 0 in physics. You have to repeat the course. Don't say pass. For you may be happy, but university will not accept. Understood? So don't take the average of the numbers which are far away. Average is only for the numbers which are close to each other. So you should know all the G values. Should come 9.7, 9.8, 9.7, 9.9, 9.5, 9.7 like that. Okay? If you get 9.4, let us say you get 9.4.
Yeah.
Don't panic. Check all the values. All the G should come to 9.4. This is systematic error. For example, some students get 9.3, some students get 9.3.
Okay.
First reading. Then the doctor 9.8, why 9.3? I said to the second one. He gets 9.34. Then he says, doctor, still coming same. I said to the third one. He's get 9.28. See, he's hovering around 9.3, right? So set up problem with the setup. This is an error of 0.5 meter per second square. So if you're getting one value, they should be around that. All the values should be around that. It should not happen that, and it cannot be 8.8, 9.4, okay, 9.5, okay, not 7.2 and around that. No, understood? No. So it can have error of 0.5, but not error of 3. I will throw this out from the lab. You got the point? So there is a check for every experiment. Every experiment you can check you're right or wrong. You got the point? Don't blindly do and give the readings. Last time students give reading with G is equal to 20 meter per second square. I said, what is this? He said, doctor, I got this. I said, okay. What can you do? Yeah, this is put here, okay? Now what's the next step? When you pull this, this will be in a time and pendulum. This should be in a time and pendulum. Time and pendulum, okay? Time and pendulum. For the simple pendulum, time and pendulum, okay? Yeah. Now, press the star, and see, leave with a small angle, only for the small angle. See, don't do this. The formula that 4 pi square times L over T square is only for small angles. The formula you're using for G is acceptable only for small angles. Angle should not exceed 10 degrees. Angle should not exceed 10 degrees. So, small angle, leave it. See, there's the time. Okay, time comes. Okay, angle reset. Bring star. See, leave it. See, and answer. Okay, so this is the time period. So you have to, how will you check? You must get the t values all same close to each other. All the t values should be close to each other.
Take the average?
Yeah, you take the same like that. Then you find the G, all the G should be close to each other. Once you have done that much, we are all sure that you are done. You got 18 marks in the pocket. 15 to 18 straight goes to pocket. If you write the unit, if you write the formula, if you find this, 15 to 18 in the pocket. So you're safe. This is the time, Okay. Time period. So you use this to calculate the G. 4 pi square multiplied by L over T square. Length and calculate. That you have to do by yourself. That I can teach. That is in the paper. Finish this. Next.